In this section, we want to continue our work with factoring by looking at the factorizations for the sum of two cubes and the difference of two cubes. Let's take a look at our first problem. I want to factor completely a cubed plus 8. Well, it looks like it's going to be the sum of two cubes, a cubed and 2 cubed. So I know that if I factor x cubed plus y cubed, I've memorized the factorization for this. It's x plus y times x squared minus xy plus y squared. So this is the factorization for x cubed plus y cubed. X plus y times x squared minus xy plus y squared. Okay, now you have to believe this. If you don't believe this, what you have to do is multiply these back out and see that you get x cubed plus y cubed. You do. So when I factor x cubed plus y cubed, it factors into this right here. Once I trust that factorization, then it's a matter of being able to apply it. So anything that has the form something cubed plus something else cubed is going to factor like this. Well, the thing I'm trying to factor, a cubed plus 8, has that form. It looks like a cubed plus 2 cubed. So if I don't have to actually write this down if I don't want to, but this is the way I think of it, a cubed plus 2 cubed. Well, if this factors this way, then a cubed plus 2 cubed is going to factor this way. A plus 2, a squared minus 2a plus 4. Now, how do I know that this is going to be a subtraction sign, this is going to be a plus sign? I know because I trust this factorization formula. I've multiplied this out myself many times and see every time that this times this is x cubed plus y cubed. So if I want to go in the other direction and factor this, I have to write it down this way. So I remember it like this. If I'm going to factor a cubed plus 2 cubed, the first thing I see is the binomial that looks like this without the cubes on it, just a plus 2. Then the trinomial after that, the first term is the square of this, the last term is the square of this, and the middle term right here, I just multiply these two together and change the sign. This sign always matches this sign, and this sign is always a change from this sign. The last sign is always positive. Let's look at another problem. I have y cubed minus 64. Well, to me, this looks like y cubed minus 4 cubed. So if I was to try to factor, let's say, a cubed minus b cubed with my factorization formula, I know this factors this way. A minus b, it's just a binomial that looks like this without the cubes on it, just a minus b. What comes next is a squared, change this sign, plus, multiply them together, ab, and then plus b squared. Again, how do I know it looks like this? I memorized it, okay? First of all, I have to trust it before I memorize it. How do I trust it? I multiply these two things together and I get a cubed minus b cubed. Then once I've trusted it like this, I can memorize it, and then I have to try to apply it. So that's what we're doing right here. So if this factors this way, then y cubed minus 4 is going to factor this way. Y minus 4. It looks just like the binomial here of this without the cubes on it. Then I go to the trinomial, I square this, y squared. I change this sign plus, I multiply 4 times y, and then I square the last term, 16. Now, multiply y minus 4 times this, you know what you'll get? Y cubed minus 64. You have to, because that formula always works. Let's look at another problem. 8x cubed minus 27y cubed. Okay, so this looks like 2x quantity cubed minus 3y quantity cubed. So I know that's going to factor as 2x minus 3y. I just write down the binomial that looks like this without the cubes on it. I square this term, 9 plus. I multiply 3y times 2x, I get 6xy. And then I square the last term, 9y squared. It has to work as long as I've multiplied that formula. I know when I multiply these two things out, I'm going to get 8x cubed minus 27y cubed. Let's look at another problem. 27x cubed minus 1/27. Well, this looks like 3x quantity cubed minus 1/3 quantity cubed. I don't care what these terms here look like as long as they're cubes. So 3x cubed and 1/3 cubed. then I know that this factorization is going to look like this. 3x minus 1/3. I just write them down without the cubes. I square this term, 9x squared. I change this sign, plus. I multiply these two together. 1/3 times 3x is x. And then I square the last term, 1/9. That's the factorization of this, and I got it because I've memorized that factorization formula for the difference of two cubes. Here's another problem. Problem number 5, I have 64x to the 6th minus y to the 6th. So here I have some 6th powers, which I can think of as squares cubed or cubes squared. So I can actually, it turns out, look at this problem two different ways. I can look at it as if the form of it is of the difference of two cubes, or I can look at it as if the form is the difference of two squares. Now I'll just tell you that from experience I know that it's better to look at this as the difference of two squares. So we'll work the problem that way. If you want to try it again yourself, looking at it as the difference of two cubes, go ahead and you'll see what the difference is. Both methods will give you a correct answer. One method just gives you a couple more factors than the other method. So I'm going to look at this as the difference of two squares. Here we go. I'm going to look at this as 8x cubed squared minus y cubed squared. This is still 64x to the 6th. This is still y to the 6th. But the form now is of the difference of two squares. So I know when I have the difference of two squares, they always factor into the sum. 8x cubed plus y cubed times the difference, 8x cubed minus y cubed. So difference of two squares, their sum times their difference. Now I look at them and I say, oh, that looks like the sum of two cubes, and that looks like the difference of two cubes. So I'm going to factor this, which is the sum of two cubes, as 2x plus y times 4x squared. Change the sign, multiply 2x times y, 2xy, square the last term, plus y squared. That's the factorization of this 8x cubed plus y cubed. Looks like that. Now I'll factor this. 8x minus y. Whoops, take that back. 2x minus y times square of this, 4x squared. Change the sign, plus. Y times 2x is 2xy. And then square the last term, y squared. Kind of messy there, but you'll see. Here is the complete factorization of this original thing right here. You can try to factor this trinomial and this trinomial, but you'll see there's no two binomials to multiply to get these two things. So this is factored completely. Now, if you've gotten to this point in the problem set, you're looking at these problems here where it's the sum or difference of two 6th powers. Okay, with the difference of two 6th powers, you have a choice. You can factor as the sum or difference. You can factor as the difference of two cubes or the difference of two squares. That's all extra stuff. If you've gotten to this point, you've done a lot of factoring to there with the sum and difference of two cubes, and you've done a good job. These are kind of extra problems just to see how far that you can take this.